Hello everyone. In this video, we are going to talk about several questions regarding area and perimeter of plane figures. The question will be taken from a new syllabus, Mathematics 7th edition first book. This will be book for 7th grader. We are going to discuss about exercise 13A, page 345. If you have the book with you, we are going to discuss number 6 all the way to number 17. So let's start by seeing our first question, which is in number 6. The circular portions of the following figures are semicircles. For each of the following figures, find 1. Its perimeter, 2. Its area. Well, we are going to discuss number 6. Let's start with A. We had a shape, a rectangle shape with a semicircle on each side. I know that it seems like a square. However, we may not assume it is a square unless the books give us some information about it. And then from the left side to the right side, we have it as 36 centimeter. And the height of the rectangular itself is 21 centimeter. So how do we count these shapes or this figure? Let's start with the perimeter. To find the perimeter, you just simply have to add up all the outer part of the figure. Let's assume that this is a field, and then you are asked to run around the field. Then how will you do it? You will start from one point, you will go all the way, and then you will turn around, go all the way, and then turn around again until you reach your first point. That's what it means by perimeter. So in this case, perimeter means I will add up this length, which I don't know yet how long it is. You cannot say that this is 21 because there is no sign that tells you that the length and the breadth is the same. So we cannot assume that. And then I will plus with this perimeter of a semicircle, another line, another length, and then another perimeter of semicircle. What we will do is, since we know that the height of the rectangular is 21, we know that the diameter of the semicircle is 21 as well. Therefore, we have a radius of 10.5. It is the same with the other semicircle, 10.5. Since we know that from the left to the right side is 36 and each radius of the semicircle is 10.5, it leaves us 15 in the middle. 36 minus 10.5 minus 10.5, we will have 15 centimeter for the length. So what is the perimeter of the figures? We just have to add it up. Let's start from this point. First, we are going straight, so it is 15 centimeter plus half of the circle. How do we find half of the circle? The perimeter of half of the circle is, we know that pi times d is the perimeter of a circle, and then we divide it by 2. And then plus another 15. And then plus another pi times d divided by 2. Then we will continue with 15 plus, we will use 20⁷ for the pi because the diameter is, if you know the radius 10.5, the diameter will be twice of it, which means 21 divided by 2 plus 15 plus the same thing. You will write the same because as you can see, this is the same thing. So when you cross this, it will be 3. 22 times 3 will be 66 out of 2. Right? And then we will just have to add it up. 15 plus 66 divided by 2 is 33 plus 15 plus 33. So at the end, we will have 96 centimeter as a perimeter. That's how we will find the perimeter of this figure. Let's move on to our second question, which is about the area of the figure. To find the area of the figure, what you will need to do is to add up all the area that is here. So the area of the figures will be the area of the semicircle plus the area of the rectangle plus the area of the semicircles. We can write it like this. Area of the semicircle plus area of the rectangle plus area of the semicircle. Since we know that these two semicircles are the same semicircle, we can just add up these two semicircles, become the area of the circle. The area of the circle plus the area of the rectangle. How do you find the area of the circle? Area of the circle is pi or 22/7 times, since the radius is 10.5, 10.5 times 10.5 pi r square, okay? Plus area of the rectangular will be 21 times 15. Then after this, you just have to count it. It will be 1.5 when you divide by 7. And then I will use the help of my calculator here to save the time. 1.5 times 10.5. We will have 346.5 for the circle, and we will have 21 times 15, 315 for the rectangular. So when you sum it up, it will be 661.5 centimeter square. We put square there because it is an area, so it is centimeter square. 661. So that's about our first figure. Let's move on to our second figure. Let's see our second figures. Here we have a triangle which with the same base and height, and then we also had a semicircle with the radius of 5 centimeter, and the longest side of the triangle is square root of 200. Okay, this one is interesting. B. So we had this square root of 200, and then the same base and height, plus a radius of 5 centimeter. Let's start with the perimeter. How do you find the perimeter? Let's assume we will start running from this point of the field, and then you will go all the way, another half circle, and then this one line. So it's simple. We know that this long line, or the longest side of the triangle as square root of 200, and then we will add the half circle, which is pi d divided by 2, and then you will plus, because the base of the triangle is the same with the height of the triangle, and then we know the height of the triangle is the same with the diameter of the circle. The diameter of the circle is 10 because the radius is 5, right? So diameter is twice, so it will be 10. So the base will be 10 as well, so plus base. I will just write it here first, and then we will count it. We know that the base is 10. Pi plus d. Since the diameter is 10, What we are going to use is not 22/7. We are going to use 3.14 times 10 divided by 2. Then how about square root of 200? Square root of 200 means square root of 2 times 10 times 10. That's why we will get 10 square root of 2. If you do not know how to count this, try to search in Google how to solve square root of 200, and then Google basically will tell you the way on doing so. Then we will have 10 square root of 2 plus, if you count this, it will be 31.4 divided by 2. Then we will have 15.7 plus 10. So the perimeter of the figure is 10 square root of 2 plus 25.7. So that's about the perimeter of the figures. Let's move on to the area of the figures. Let me check something on my book. There is another way. If you had your calculator with you, you can actually finish this up by just pressing 10 square root of 2 plus 25.7. It will give us 39. It will give us 39.84. So if you have your calculator, you may want to finish that up. If you do not have a calculator, then you stick with 10 square root of 2 plus 25.7. That one is easy. Let's move on with the area. So to get the area of the figures, what you will do is you will write the formula first. The area will be the area of the triangle plus the area of the semicircle. We know the area of the triangle is base times height divided by 2. And then the area of the semicircle is pi r square divided by 2. If you, as you notice that this question is actually pretty nice. It gives us both the denominator as 2, so we don't have to change the denominator later on. So the area will be base times height. The base is 10 because base the same with height, and then the height is 10 since it is the same with the diameter of the semicircle. So we have 10 times 10, which is 100 divided by 2. I will not divide it. I know that we can divide it into 50, but I will leave it like that just to make sure that I can, maybe I will need it to add with this fraction here. So in this fraction, I will have 3.14 times the r, radius is 5, so 5 square 25 divided by 2. Then you will count this. I will use the help of my calculator again to count 3.14 times 25. And then divide the result by 2. This is easier. So in here we have 50 plus 39.25. And then at the end we will have 89.25 centimeters squared. So do you have to use calculator to count this? No, you can actually count this manually. However, for the sake of time, I'm going to count basically with my calculator just to save the time for the purpose of time. Okay, so that's about the second figure. Let's see the third figure here. So in C, in the third figure, we will have half of two small semicircle with one big semicircle. These figures, we had this big semicircle with two small semicircle. We will want to find, I'm sorry, it's not the area. What we are going to try to find first is the perimeter of the figures. And how do you find the perimeter of the figures? You will add up. Let's say that you start at one point. You will need to go around it, around the big semicircle, and then you will go twice the small semicircle. When I talk about the semicircle, means half of the circle. Then how do you find it? Let's start with the big semicircle. The big semicircle is pi times diameter. The diameter of the semicircle is 18, the big one, divided by 2 because it's only half of it. Plus, you will need to find the perimeter of this small semicircle, and then you will times it by 2 because it's twice. So instead of going with the semicircle, I will just assume this one circle. So it will be pi times d. The diameter of the small circle will be 9. And then after this, you will have 18 divided by 2, 9. So you will have pi times 9 plus pi times 9. I'm sorry, it might be not clear for you. Let me write it again. Pi times 9 plus pi times 9. You can, of course, count it manually, 3.14 times 9 plus 3.14 times 9. However, there is another approach. You can just do it 18 times pi, because it's 9 pi plus 9 pi. Going with algebra, it will be 18 pi. And 18 pi, you just have to count it manually. But we are going to count with calculator again for the sake of time. It will be 56.5. 56.5 centimeter. That will be our perimeter of the figures. Okay? Let's move on with the area of the figures. The area is a lot easier because we just have to add the half of the big circle or this semicircle, and then plus 2 of this small semicircle, which means 1 small circle, right? So we will just insert the formula. Pi times, we will go with the big one first. To find the area of the semicircle, it will be pi r square divided by 2. However, for the small one, I will just put pi r square. I do not divide it by 2 because I will times 2 at the end. So why should I divide it, right? In the first area, in the area of the big semicircle, we will have 3.14 times, the radius will be 9 square or 81 divided by 2 plus 3.14, the radius. Since the diameter of the small circle is 9, the radius will be 4.5, so it will be 4.5. Can you see that? Yeah. 4.5 square. You don't have to divide this by 2 because there will be 2 semicircles, so it's 1 small circle anyway. So we will have to count this. Can you count this manually? Yes, but it will take time. Times 81, and then you divide this by 2, you get 127.17 plus, when you count that, 3.14 times 4.5 square will be 63.585. And then when you add up these two numbers, you will have 190.7. 190.7 centimeters square. That will be the area for the third figure on number 6. Even though the answer key tells you it's 191, because when you are using calculator, you can just insert the pi right away instead of doing it this way. So that will be for number 6. Let's go with number 7 this time. Let's check the question on our number 7. So, in the figure, 4 quadrants, each of radius 2 meters, are removed from a rectangle. Find 1, the perimeter, 2, the area of the figure. So, we had this rectangle. We had this rectangle. The length of the rectangle is 9. That is given in the question. And then I will remove 4 quadrants there. Quadrants means quarter of a circle. With the radius of 2 each. So this is 2, 2, 2, 2, 2, 2, 2, and 2. Then we know that this side is 3 and 3. This equal to this. Well, obviously you can count the length of the rectangle because all the way is 9, but I take away 2 and 2 for the quadrant, so it leaves me 5 in the middle here and 5 in the middle here, okay? For the, let's start with the perimeter. We will do it a little bit with shortcut. The obvious way is actually 5 plus this quadrant plus 3 plus the quadrant plus 5 plus the quadrant plus 3 plus the quadrant. But since we will go with 4 quadrant, I will just count it as one circle. So I will insert that first. Pi times d, one circle. What is the diameter? The diameter will be, this will be the circle that we are talking about. This is only a quarter of it. So if it's a full circle, let's say that it is a full circle. Can you imagine it? The radius of the circle will be twice of this, which means 4. So later on, the diameter will be 4, okay? And then you will plus 5, 3, 5, and 3. So it will be plus 16. What you will do is you will use 3.14. Since the diameter is 4 times 4 plus 16. When you count that, you will get 3.14 times 4, 12.56 plus 16, you will end up with 28.56 for the perimeter. 28.56 centimeter or 28.6 centimeter. That's for the perimeter. Let's move on with the area. The area of the figures, since I remove this quadrant, so what I'm going to do is I will just count the area of the rectangle. So the total area will be the area of the rectangle. And then I will minus. Actually, I will minus a quarter, a quarter, a quarter, a quarter. Since I have 4 a quarter, so it will be combined as one circle. So it will be minus the area of a circle, right? What is the area of the rectangle? We know that the length is 9 and the height or the breadth will be 3 plus 2 plus 2, which is 7. So 9 times 7, which will give us 63 later on, minus the area of the circle. The area of the circle is pi r square. The r here is 2. So 3.14 times 2 times 2, which is 3.14 times 4. This will give us 63 minus 3.14 times 4. 12.56. So when you minus it, it will give you 50.44 or 50.5 for the area, 50.4 for the area of this figure. That's how you do number 7. Let's move on with number 8. Let's see the question in number 8. The perimeter of a circle of a rectangular field is 70 meters and its length is 15 meters longer than its breadth. The field is surrounded by a concrete path as shown in the figure. Find the area of the path. Well, great. So this number 8, we has a rectangular field. So we have this rectangular field. However, this field is surrounded by a concrete path. Okay, this is, I'm sorry, I draw it wrong. It will be like this. I need to make it a little bigger so that I can write a number there. Well, as you can see from the question, the field has the length. So this will be the breadth, and then this will be the length of the field itself, okay? We are talking about the field only, not about the path surrounding it. Since this is L, but the question tells us that the length is actually 15 meters longer than the breadth. So I can just write L is actually 15 meters longer, so 15 plus B. That's actually the length of the rectangle, of the field itself. We do not see the path first. Now we need to find what is the length and what is the breadth of the field itself. We know that the perimeter is 70 meters. So 70 meters is actually length plus breadth plus length plus breadth, right? So we will have 15 plus breadth, this is the length, plus the breadth itself, plus the length again, which is 15 plus breadth, plus the final breadth. So we had this 1530 plus 4 breadth or 4b, and then we have 70 here. So with algebra you will get 4b equal to 40, and then the breadth will be 10. Since we know the length is 15 more, so the length will be 25. That's how you will do, how you will get the breadth and the length of the field. Then we will erase this since we are done with that. However, we will leave the information and we will move the information to the top. Breadth is equal to 10. This is meter anyway. And then the length will be 15. This information, the length will be 25. This information will be useful later on. Next, we are going to count the path. So the easy way is actually I find this big rectangle and then I take away the field, so it will leave me the path only, right? So to count this big rectangle, I need the length and the breadth of the big rectangle. Luckily, the book tells us that this size is 2.5. But then we have 2 from on the left and on the right, which means it will add up 5 meters longer than the field length. We have the field length as 25, so the length of the big rectangle which will be 30 or 25 plus 5, right? For the breadth itself, it has 5. The path is 5 meters. 5 meters each, and then you have 2 of that, so it will add up 10 to the breadth of the field. The breadth of the field is 10, so 10 plus 10 will be 20. Now we had all this formula. We had the breadth of the field, the length of the field, the breadth and the length of the big triangle, rectangle. So what we are going to do is, we are going to, the area will be, we are going to count the big one first, which is 20 times 30, minus the area of the small, which is 25 times 10. So we will have 600 minus 250, leave us with 350. I'm sorry, not centimeter, but meter squared. That's it for number 8. Quite easy. Let's move on with number 9. Number 9, the question in number 9 is, in the figure, AD is 23 meter, DP is 7 meter, and BR 13.5 meter. If P is directly above R, find the area of the shaded region. Okay, so number 9, we had a rectangle, some sort, and then we have this shape inside. I'm sorry, it should be right on the top of it. Yeah, it will be something like this and something like this. So we need to find the area of the shaded part. We know that the height of the rectangle is 23. And then we have this 7. And this is 13.5. Just by seeing the picture, it's actually pretty easy to count this. So this is what I'm going to do. If you understand the basic formula of a triangle, you know that actually triangle is only half of the rectangle. So let's say that I cut it this way and I cut it this way. You will see that I actually have 1, 2, 3, 4 triangle here. This is the first triangle that I had. This triangle is just half of this rectangle. Right? I'm sorry, it's not a perfect rectangle. Should be perfect. So this is just half of this rectangle, this small rectangle. The same with the second triangle here. In the second triangle here, I hope you can see it. This triangle is actually just half of the rectangle. The same thing with the other triangle, this third triangle. Just half of this big triangle, a rectangle. And the last triangle also just half of this bottom rectangle. So basically, this fourth triangle that I had here is actually half, only half of all the rectangle. So I can say that this shaded part is actually half of the big rectangle, right? So how do you get the area of the shaded region? The area will be 23 times, why 23? Because it's the length of the rectangle. This, we need the breadth of the rectangle. It is 7, so total will be 20.5 divided by 2. So it will be 23 times 20.5 divided by 2 will leave us with 235.75. 235.75. Well, quite easy, right? Number 10. The last number for part 1. Number 10. Number 10. Let's see the question first. In the figure, AB is 20 meter, BC is 21 meter, AD is 10 meter, and DE is 10.5 meter. Find the area of the shaded region. So you had one triangle here, and then you will have another triangle. So when we are dealing with triangle, you need to make sure you know where is the perpendicular or the 90-degree part, because it will be your base and height. We will have 21 here, we will have 20 at the bottom. This 20 will be from this side to this side, all the way, 20. And then you will have 10. 10 is from A to D, so only to midpoint. And then this is 10.5. So how do you get the shaded region part? Simple. The big triangle, you throw away the small triangle. Let's start with the big triangle. So the area of the shaded region will be this big triangle. How do you get that? Since triangle, so it will be base times height divided by 2, right? So the base is 20 times height, 21 divided by 2. That is the big triangle. And then you will minus the small triangle. What is the small triangle? If you see this triangle, you see the perpendicular line. You see the perpendicular here. So this 10 and this 10.5 will be the base and the height. It doesn't matter which one is the base, which one is the height. You just have to write it times 10.5 and then divided by 2. You will count this. This will give you 210 minus, this will give you 52.5. Am I correct? Yes. And then when you minus it, it will give you 157.5. That will be the area of number 10. That's it for number 10.